Good morning, everyone. Today I would like to speak to you about a project that I developed more or less 3 years ago with my team concerning the reuse of an historical building, an historical Italian villa built in the 16th century and now used like a location of the University of Bologna. And so the main goal of this project is the necessity to adequate the existing building to the Italian fire prevention rules. First of all, we start with the building description. We consider that the building is a four floor set, 1 basement floor, and 3 above ground floors. We have 3 emergency staircases into the building. The main one that you can see in the center of the in the bottom part of the plan, and is the main staircase is an historical staircase. And we have 7 final exits all around the shape of the building, and we have some internal fire compartment that we implement in our project to reduce the spread of fire in case of fire. The activity description, we consider that it's an international school for postgraduate students, so we have that come from all around the world. And inside the building we have classrooms, the study halls, a kitchen and a dining hall, the gym, an administrative office, and 2 meeting rooms for internal convention. And which are the fire protection systems that are already installed inside the building. We have the fire detection system that protect the wall areas of all the areas of the activity, an internal hose real network, and we implement the existing vocal alarm system, the evac system, in order to reduce the travel time, the evacuation time, the per movement time. The occupant description, we consider that the occupants are familiar because the course have a duration of more or less 6 months, and so people know the building and are awake because there is no dormitory inside the building, and so we classify the people inside the building like type R according to ISO standard. We consider that inside the building there are at the same time, in the worst case, about 250 people, and we consider in the management of the safety plan that many of them are foreign, and so all the communication needs to be gave in more than one, not only in Italian language. Okay. So, which are the critical points? The main critical point of this project is that the Italian fire rules require that all the staircases are far separated from the rest of the building, of the areas, or staircases are external, and it's impossible for us to adequate to this prescription because we have some historical restriction on the building, on the stairs, on the main stair inside the building, and on the facade of the building, and so we cannot modify internal configuration, internal layout of the main staircases. So it's not possible for us to install new fire doors or modify the walls in order to have the fire separation, and it's not possible to realize an external staircases because it's not possible to modify the facade of the building. And so it's necessary to pass from the prescriptive method to a performance-based design approach. And which are the fire safety strategies that we developed in the in this approach in order to reach an adequate safety level? First of all, the first measure that we we developed is an intelligent active dynamics Signage system that I explain later. And then we modify and substitute the existing 42 materials with new ones that have a classification for the reaction to fire in order to reduce the fire growth in case of emergency, in case of fire. And we install new fire rating doors in order to improve the number of fire compartments inside the building, in order to reduce the spread of fire, the spread of smoke from inside the building. And we calculate the evacuation time with an end calculation method, and also with Egress software, simulation software. And then we did a safety analysis in order to evaluate the available time that person have for evacuating the building. And we improve the development and we improve the safety procedure in case of fire inside the activity. So we improve the management level, the safety management level of the activity. So which is the main philosophy of the intelligent active dynamics Signage system is that a system that can modify the egress route, the egress path in case of fire based on the position of the fire. So the fire detection system identifies the position of the fire, and a system modify the status of the signages that are installed in the building, modify the grass that are available, the grass routes that are available, and the grass routes that are not available. And in this way, we can avoid that many people go from the starting zone, go out through a fire zone. But the emergency Signage avoid that people go through the fire zone, and in this way, and this system change and modify its status according to the position to the fire. And so you can see that we install this dynamic Signage all in all the building, and we developed a matrix in which for every fire scenario, we indicated the status of every dynamic Signage inside the building. And then we did the calculation of the evacuation time with for the RSAT philosophy, the concept, and according to the values that are proposed in the ISO standard. We pay main and particular attention to the time, to the calculation of the time for passage, because in this case, with some egress routes that could be not available, there are many areas with a great number of people or person inside, and so the density is high. So we have a crowd in some place, and we need to calculate the reduction of the speed and the evacuation time due to the density, due to the crowd that we have in some points. and then we check the values that we calculate with the and calculation method with the software pathfinder. And you can see in this slide the main input data that we insert inside the software, and then we verify and compare the value of used with that we have with the hand calculation method and the value of Pathfinder, and the variation is about 10% of the time, and the hand calculation gave us a more conservative result. So we use for the evaluation for our project, we use the more conservative values. But it's important for us because in this way we have a comparison between our calculation and the values of the softwares, and so we can check if the hand calculation method are correct or incorrect. And so for every design for a scenario, we calculate the R set, consider also a safety margin, safety factor according to Italian regulation, and then we develop safety analysis using the software FDS. And for every fire scenario, we consider some parameters connected to the life safety, so the visibility, the temperature, the heat radiation, and the toxicity of the air. And the threshold parameters is defined according to Italian fire code. So we consider a 10 meter of visibility at 2 meters from the floor, a 60 Celsius degree at 2 meters from the floors, 2.5 kilowatt per square meter in at 2 meters from floors for heat radiation, and for FED we consider 0.1 as a threshold value. And then, so for every fire scenario that we evaluate according to the Italian fire code, but also with an FPA 101 and SPA handbook. So we evaluate the 4 fire scenarios that represent the worst case, and then we did the safety analysis, and the result of the safety analysis given from the table below that we can see in the bottom part of the slide. So we compare the asset of every value that we evaluate with the R set that we calculate with the calculation method, and verify if this comparison is good or not good for our goals. So, which are the conclusion of this study? That the analysis of human wayfinding has led to develop a new strategy for the evacuation in emergency. The intelligent active dynamics Signage system has been considered to redirect people, indicating the viable and not viable exits, depending on the position of the fire source, identified by an automatic detection system. We have a low impact of the building, since it do not need a layout modification, and the active intelligent wayfind system monitor human egress process, spreading of the fire and damage to the building, and suggest the best escape path depending on this condition. And so the performance-based design approach leads to guarantee that the system is reach an adequate safety level, even if we cannot respect, cannot punctually respect the prescriptive Italian rules. So you can see some reference that we use. There are many Italian reference, but also international reference that we use for the development of this project. And thank you very much for the attention. If you have any question, please do not hesitate. Goodbye.
So when simulating the evacuation, did you run multiple simulations and evaluate them statistically? And in the case of active navigation, according to the movement of people, is there present any predictive simulation?
Okay, so yes, we did several simulation considering a different location of people inside the building according to the density that we consider the real density, and the result that I show on the slide, and then are the result of different S.r.l simulation, and so we compare the mean value with the calculation, the hand calculation data that we have in output of the application of the ISO standard.
Okay, and then in the case of active navigation, was there any predictive simulation of just the movement of people, predicting where they would be over time?
And in this case, we don't we didn't do any predictive simulation, because we prefer to follow the ISO standard and the data on the ISO standard, also in according with the authority that prefer to have a calculation according to a standard, respect to have a calculation from a software. Actually, in Italy, the Egress simulation with software are not yet considering as the only solution, the only way, and so we needed to use the software and the Egress simulation software as a verification and validation of the data given by the standard.
Okay, and then for the fire, did you consider breakage of glass in the room, which might increase fire growth?
Yes, of course. We run several simulations considering different ventilation inside. So we consider also the possibility to have some windows open, and we also consider in some cases the blockage of glass. But it's not easy to simulate the correct temperature, the right temperature of glass blockage, because there are very different values on literature about this thematic, this point, and so we prefer to run several simulations with different ventilation conditions in order to have the real picture of the situation.
Okay, and then what did you use for design fires?
We used FDS as a software to modeling the fire. And the design fire, we evaluate we have some national standard that gave us some kind of fire for different activities, and we implement the data of the Italian standard with our experience and our evaluation, because we pay a particular attention in the substitution of the furniture materials inside the building. So we have inside the building the work quantity of materials that are classified for the reaction to fire, and so we use the real configuration of the activity to simulate the design fire and to evaluate the design fire.
Okay, and just as a real quick about like what size in terms of heat release rate, what are we looking at?
So we design fire in terms of heat release rate. We consider we evaluate some different cases in order to consider the different value of ventilation, because in this situation the value of the peak of the heat release rate is given by ventilation, because our small or medium rooms, and often with closed windows, and so we calculate with formula the peak of heat release rate, and then we compare also in this case we compare our handmade calculation with the results of the FDS in order to compare the input heat release curve with the output heat release curve. Mm-hmm. And also we consider that all the doors of the classrooms were being implemented with a self-closing drive on the door connected to the fire detection system, in order to close every door in case of fire. And we also simulated the failure, the fault of this drive, self-closing drive on the door, in order to evaluate several conditions.
Okay, excellent. Well, thank you for the great presentation and this Q&A session. Thanks for joining us here live, and we'll go ahead and transition back to the other slide. So thank you so much. Take care. Ciao.
Thank you. Bye-bye.